All right. Sorry for the delay. Just getting finishing touches set up here, and we'll get started in a second. Okay, sorry for the delay there. I realized I got everything set up with my environment, and I forgot to correctly copy in the link for the stream. So I just updated that. Obviously, if you're hearing me say this, you found the link. Okay, cool. So system check, we're up and running. So as usual, it looks like we already have a question here, which is great. Just a quick reminder for everybody, if you're new or whatever, but I just like to reinforce this every time. You know, welcome to Study Hall. This is a venue for you to ask questions and have me go over your answers or go over answers to them. Please provide a link in the thread to the person who posted one. This is great. It tells me the challenge number and then the link, and then they gave me some code some of their code for me to debug to go through that, which is optional. You don't have to provide your code. but you are welcome to if you want me to go through it specifically. So that's a good model. If you have a question, ask like they're asking. So yeah, just include the link, and let me know how to get to it, and I'll be happy to go over it on stream. And then if I don't see a question, I'll probably just give folks a minute to like get questions in, and then just to save us the dead air, I might go through the learn material if there's nothing else to do. Cool. All right. So let's start with the question on the table. I'm glad we got a question right off the bat. I always like when that happens. I think that's what makes these like fun and useful for everybody. Makes it fun for me. I don't know. Okay, and then this is challenge 2, remove or add. Okay, I'm just going to copy all this stuff and we'll stick it in a doc string. Okay, well, let's see if I can use my text editor first. Okay, there we go. Here's an example, so we'll just move out this example. This is basically a complete test. We have a result. It's taking in this dictionary, which I'm going to just break this out. We'll call this some dictionary. Dictionary equals this. And then we'll say some list equals this. Okay. And then this will just make it easier if I want to like make other tests real quick or something. Yeah. So let me take a look at the code. I'll bring that in, and then I'll kind of go through everything and kind of try to go from there. And we also have an error that is being reported here. Okay, so this is the error this person is getting. Okay, so it says this traceback error, most recent last call. This is the file in learn. So this is an error. Well, it's an assertion error, which means it was expecting to find a given answer, but it didn't find that answer. So we'll kind of come back to this in a second here. First, I'll go through and kind of debug this code, and then we'll look at the context of that error. Okay. So write a function called add remove, takes into values. First parameter will be a set. Okay, so that's, I don't know why I called that D. This is obviously a set, but I just saw the curly brackets, and I just like automatically assume that it's a dictionary, even though it's clearly not. I'm going to do this. I prefer to use just like a list and then just cast it as a set, because to me, curly brackets just always mean a dictionary. And there are some cases where Python can throw an error because it's clear to you that you meant, if you're using curly brackets, that you're meaning a dict or a set, but Python tends to assume that's going to mean a dictionary instead of a set. So it can cause some disparity between your understanding and Python's understanding, and obviously my understanding as well, because, you know, I got confused. Okay, so the first parameter will be a set that will have, did I call that? Yeah, I did call that a set. A set that will have an unknown count of numbers or letters. So an unknown number of elements, I guess, which can be numbers or letters. The second parameter will be a list that also has an unknown count of letters or numbers. Okay. If a value in the list is not also in the set, it should be added. If the value is in the set, it should be removed. Interesting. Well, that's just very, very interesting. So it looks like here we have our set 1, 2, 3, and this says our list has 1 and A in it, so this should have A in it, but we should remove 1. Okay. What an interesting thing. So I'm thinking, I'm just like, I'm brainstorming if there's like a really kind of cool, succinct way of doing this, but I think just the accumulation approach is probably going to do us just fine. Okay. So this is going to go through, we're going to iterate through the list. It looks like, and this is the user submitted code. So it looks like they're iterating through the list. And then if the item, for item in list, if the item is not in the set, set.add item, I guess, else set.remove. Let's try that out. A23, okay, that does look like it works. It passes our test. I want to see what the original, I should have ran the original code first just to check it out. 2.3, okay. So this is just a, this is a nice condition. If the item's not in the set, we add it. If it is in the set, then we remove it. So this is just a pretty straightforward if-else thing. I bet you this is gonna pass and learn. Let's see. It may or may not. Sometimes there's little gotchas and things that I don't see. Okay, looks like it's good. That works. So it looks like you're just missing the else. And yeah, it looks like this is the same logic. It's checking the opposite condition. If val in set, then remove it, else add it. So it's the negative condition, but it's the same logic. It's just, 6 of one, half a dozen of the other sort of thing. Let's look at this. I appreciate getting the error submitted. That's all. That's really good to go through. Like, we didn't need to go through it, but yeah. So I do want to talk about like how to read something like this, how to go through something like this. So this is the error. Generally, errors, the most useful information is towards the bottom rather than towards the top. All of this other stuff around this F and the formatting and the fail, whatever, these are sort of just formatting things that we put in as standard, but this is the actual error. And if we do, let's see. Oh, I literally, oh, wait. Yeah, I do. I have it right here. Is that complete? I just want to make sure it's complete. Yes. Okay. So this is sort of where the magic happens. And I can actually model, this is essentially the test and learn that's failing. So we can actually model this with assert, oops, don't want to delete, add, or remove. Assert, add, remove with these inputs is equal to this set. Excuse me. And then for the sake, for my own sake, I'm just going to just cast this as a set. Like that. See, it's the same either way, but just I prefer it this way. And I'm a little OCD about my code, so whatever. So this is essentially what's happening behind the scenes. So we don't go over assert anywhere in Learn because there's sort of other ways of modeling that behavior. But basically what this is saying is if it checks a condition, and if that condition is true, then it's like, yay. It doesn't actually say yay, but I mean, we could do it this way, and then it would say yay. So yeah, otherwise, else, print, nope. So this is the error. So basically just assert just checks this condition. If the condition is true, it doesn't throw an error. If it's false, then it throws an error. So it's useful for, it's a very simple like testing and sort of error handling tool. So if I remove this else, we'll back up this to the original code, I'm going to get an assertion error. Oops, and I'm actually going to see the syntax error there. They had a colon. Okay, so this is an assertion error, and it's failing right here, right? So basically what this is saying is, given that we call this function, whatever it returns should equal this. And it doesn't equal that. So since it doesn't equal that, we get an error. And we can actually even include an error message in our assert like this. Items in the second set are not first. Okay, let's do this. We can just put a string at the end like this. Looks a little funky, but that will actually be our error message when this assert fails. Right? So that's essentially what's happening behind the scenes with the errors in Learn. But basically the way so now that you know kind of what's happening mechanically, the way you can deal with this, and I always do like to just copy it. If I'm really like going through an error, I'll just copy paste it into my terminal so I can kind of poke around with it and whatever. Like edit it and kind of take notes on it or whatever. I'll usually comment it out. So I'll start at the bottom, and it says it's an assertion error. Okay, so I see assertion error. To me, that means somebody wrote a test that asserts that something must be true, else the program is invalid, right? So that we're opting into a voluntary error here, which means we have a test that we want it to pass. So it's failing an assertion error. That means maybe my code works, but I'm not getting the right answer. And then I can look up and find like the self.assert equals main.remove or add. Like there's a bunch of extra stuff here, but at the end of the day, it's going to include a call to your function and then something that it expects that function to return. And you can test this by going, oh, okay, well, I'll just copy that here and print like that. And then now I have a little simple print test like the one I have here, right? And then you can include this in your testing. That's what I like to do anyways. And then, locally you can make it pass that test, figure out why it's not working or whatever. Yeah. Cool. Okay. I'm not seeing any other questions at the moment. I'll give folks, I'll just put a minute on the clock. And if I don't see anything, we'll start going through the material. Cool. All right, looks like we got another one. Letter IDX. Okay. And if you would provide a link to this problem in Learn, that would be helpful. Ah, no, you're already on it. I spoke too soon. Okay. This looks like it's challenge 3. And I'll copy in the code. Cool. All right. Is this okay? Okay. I'm gonna do this test too. And just since this was part of the code that was provided like this, we'll often use this symbol as somewhat of a shorthand, like this. Certain other languages, this is actually an operator in Python that you can use in certain places. I won't get into where, but certain other languages will use this dash greater than as a right arrow to mean something's being returned. So it's generally in Python, we'll generally just use it in a comment. There are actually places where you can use that, like here, to say it should like return an int or something, but we're not going to get into that. So that might be one reason that would cause a syntax error if that was submitted in Learn. And I know we do have this example with that arrow in it like that, and I kind of would prefer that we would just have comments there, but yeah. Okay. So write a function called letteridx, track indices of where the vowels occur in a string. This function should take a word or sentence as an argument. That's word. It's case sensitive, so I treat lower and uppercase A the same, and returns a dictionary where the keys representing the vowels that occur in the sentence and the values representing, oops, I lost my place. The values representing, let me do this. Turn a dictionary where the indices where that vowel occurs in the word or list. Okay, so this is good. I like this up front here. Word lower equals word dot lower. Then we have our accumulator and for index and character in enumerate word lower. If the character is in A, E, I, O, U, Y, and we are including Y, then D sub CH equals, that's the thing. Okay, so let's look at this. The value representing the indices. So this is a bit, I think this question could stand to be rewritten. Because we need indices. We need multiple indices. So if we look at this example, the keys are strings, right? So this is the example from Learn. And this is the test from the person asking the question. So the users, I don't know. So the Learn example, if we look at this, the expected return is a dictionary with a string key and a list of indices, right? So it appears not to say that in the problem statement here. I'm looking, I don't think it says that anywhere. Okay. So I think this could stand to be rewritten to be explicit about that. So in this case, what we want to do, so if the character is in AEIOU, then we want to say D sub CH basically dot append, because it's a list, right? D sub CH should hold a list. It doesn't yet. I mean, if you're wondering like, hey, what you're appending, but where's the list? So this particular thing where you have a dictionary that contains lists as in its values. You can append to that list, right? And to be clear, if this seems confusing, like I haven't yet put that list in this dictionary, but I have put the append to the list that I don't yet have. We'll get to that in a second. But yeah, so to be clear, to just air out some common points of confusion about this particular thing, this is not appending to a dictionary. This is not appending to, I wouldn't say it's appending to the key. It's appending to a list that is located at the key at the dictionary, right? So it's in the key at the dictionary. So let's make that into a list we can append to. So this is what we want to do. And so now I got to say is if ch not in D, then we want to make d sub ch exist. Oops, and excuse me, ch not in d dot keys. To be clear about this, and I know the person who asked this question, we were working on something similar recently, but just for the benefit of everybody else here, we don't need to put dot keys here. This line is gonna work exactly the same whether we have it written like this, if ch not in D, or if ch not in D dot keys. I think convention is to just leave that off. If you don't specify keys or values, it's going to assume keys every time. I often like to just put it on just to be explicit. Like it's a note for you, for the programmer, right? So the other thing is, if you get in the habit of putting d dot keys, you're certain that you didn't mean d dot values. Like this is like, yes, I am intending explicitly to check keys, right? So if there's a problem in your program, you can it's easier to rule that out as a potential, like, maybe they meant values or something, right? Anyways, so we're going to check the keys of the dictionary like this either way, however we write it. If the character is not a key in the dictionary, then we just want to make it exist with its value, which we can't have an orphaned key, i.e. a key without a value. We can't have a value without a key. They have to be in a pair, otherwise it's not a valid entry. It's not a valid item in the dictionary in Python. So if character not in D sub ch equals empty list. So this just makes sure that, if it's not in there, it'll add it in and it'll initialize an empty list that we can append to, and then we'll append to it. So whatever we do, we append to the index, and this just makes sure that we have some place to append it to. If the character is in the dictionary, it's not going to add it in already. We'll just skip that line and we'll just go to the append. Cool. Let's try that. All right. And this is shaping up. I'm just looking at the example solution here, and it looks like it's going to be essentially the same logic. So we have our dictionary for character in enumerate word lower. They're doing the lower a little bit different. A-E-I-O-U-Y. If the character's a member, then append to it, else add it in and initialize the list with value added into it. And so this is a variation on the pattern that I showed above. Yeah, cool. Yeah, okay. So we have a question here to go over the logic regarding this nested if here, right? And I'll go over both of these versions on that particular part because it's a little bit different in either one. I would say, well, these actually are logically a little bit different, but in this case, they function exactly the same way. Okay, so the reason for this nested if, and it does have to be nested, right? It has to be, one has to be in the other. So the reason for this particular structure is, first of all, we want to see if the character is a vowel. If it's not a vowel, we have nothing to append to, we have nothing to do. Like, we just literally want to ignore it. So if it's in A-E-I-O-U-Y, do this, else pass, continue, whatever, right? Just nothing, else nothing. So that's that. And then the interior if is just here. I think about this as sort of like a safety line for line 55, right? Like it's line 55 is sort of the thing that I'm doing, right? It's like I'm appending an index into the list located at d sub ch. So I'm appending that index value of ch in the word into the list at d sub ch, right? This is the thing, this is like the point, the purpose of this whole, hey, if it's a vowel, then append its index to that list in the dictionary. But we initialize the dictionary like this. There's no key, there's no d sub ch with a list to be appended to until I create it. So before I do the append, I'm like, oh, well, before I do the append, just make sure that d sub ch exists and holds an empty list, and then we can append to it. And if d sub ch at this point, if it already does exist, then we will append to it because it already exists. If it doesn't exist, we'll make it exist with an empty list and append to it. Yeah, and then this structure here exists for the same reason. I would call this really just a variation on the prior example. In this example, we're just checking if the character is in the dictionary. So rather than saying if it's not in there, add it, we're saying if it is in there, append to the list that's already in there, else make d sub char exist with a list that contains IDX. Sometimes I'll do things this way too, but in any case, I always like to do, and this is just a personal preference, it's just, you can do whatever suits you the best, but I always like to say if the element in the dictionary is not in. To me this just makes sense because it does, just that's what I like, to just say like, okay, if it's not in there, add it, else then it is in there, so modify it. Yeah, and then this is a little bit different from what we have above because this has an if else, but to me I'm just always like, oh well, just get rid of the else, and then I can have this sort of simple idea of creating an empty list that just initializes it, and whether or not it was already in there, I'm just appending to it. And yeah, it's just the way I write it is just a matter of how I reflect how I like to think about it, but there are a number of ways to do that particular pattern. Let me know if that, I'm hoping that addressed your question about if. Let me know if you have further questions about that, or if that was helpful. Okay. Cool. One more question. In line 52, is there anything in the dictionary? Let's see. Oh, okay. So here. The question is, in line 52, is there anything in the dictionary? I'm going to take that to mean like since this is inside a loop, the first time we encounter line 52, the dictionary is empty. So this will always be run the first time it's encountered. Let's just, let's do this. We'll just see how it evolves this way. Right, so first it's empty, then we add E to it, then we add E1, 014, etc. Right? Well, I guess this just tells us every time we added a new one. Maybe, what if we did it? Well, yeah, I guess that's actually the best way to like visually answer your question, I think, to just leave it right there. So just to be extra clear, the first time we encounter line 52, D is empty because we declared it as an empty empty dictionary. Let's see if I can use my keyboard. So yeah. Awesome. All right. The floor is open for more questions. So if anybody's got one, I'll just put. Oh, there's one right there. Awesome. Wait for Slack to catch up. Ooh. Cool. So challenge 3 in unions and intersections. Okay. So write a function called continuous set. This function should take a single parameter called set1. It should return a Boolean true or false depending on whether the set is continuous set. Note, a continuous set is a set that contains all sequential integers. For example, 1, 2, 3, 5 is not continuous because I guess because it's missing 4. But 9, 8, 7, 10, 11, 12 is a continuous set even though the values are out of order. They're trying to like throw you off the scent a little bit with this last sentence. Even though the values are out of order, sets don't have an order. A set is like a jar of jelly beans. If I told you, if I handed you a jar of 1,000 jelly beans and I said like, hand me the 439th jelly bean in there, like hopefully you'd hand the jar back to me and just walk away because that's not a reasonable request, right? Or something funnier would happen. But at any rate, like you don't think about a jar of jelly beans like having a first or a last or an nth jelly bean, right? You might like line up the jelly beans in a row and say, well, they have an order there, but like that specific ordering is arbitrary. And if you did it again, you'd could just as well get a different order back out. So sets in some implementations of Python recently, I think IPython 3, sets will, like if you print them off, will often print off in a sorted form. So if the elements can be sorted, they will be. But I think it's hit or miss. This is new behavior, and honestly, I'm a little bit unclear on some of the details of it. But even though some of the very particular details about sets have recently changed, what hasn't changed is that you don't think of them as having an order, right? So this is why sets don't have an index, right? The cool thing about this is they're so easy to cast to lists, which makes it kind of nice. Okay, so let's just go for this. Continuous set takes a parameter called set1. I'm just going to call it set underscore because I feel better about that. Let's do this. Some set equals, I'm just going to steal the examples here, right? So they give us this example, which is not continuous, right? So this should give us false. And they give us this example, which is continuous. So that should give us true. Okay. So obviously both of these are going to just return none right now. I'm just making sure I don't have any other syntax errors. And I totally do. Look at that. I don't know how that happened, but whatever. I'm going to rewind until I find out where I just put a space in there when I typed it. Okay. I'm like, how did that happen? Okay, I just did it. All right. So we just expect to see false true. So I think what I would do, we'll see if this is what I would actually do. We'll see. So for num in sorted set. So the cool thing about the sorted function, is it'll take in a list or a string or a tuple or a set, and whatever it takes in as its argument, it gives a list back. It always gives a list back. So this is a list of elements, the same elements that were in set. No duplicates. It doesn't like magically have duplicates or anything, right? Because the set didn't have duplicates to make duplicates or anything. And then, yeah. So this gives me a sorted list back. And I think what I want to do, just thinking about how to do this. I think I need the index. I could either enumerate or I could zip and slice. I think enumerating is simpler. Kind of simpler. Okay, so for the index and the number in the enumerated sorted set, right? So we take the set and turn it into a sorted list. It's kind of nice because sorted both sorts it and it casts it as a list. And then we enumerate that list. Okay. And then I'll say if idx equals 0, I'm going to continue. And then from here, I'll just say if num is equal to okay, so I'm going to use this sorted set again. I'm just going to call this list. We'll just say list equals sorted set. So if num is equal to list sub idx minus 1. So idx minus 1 is the previous index. We skipped index 0 because of this. If I don't do this, then idx minus 1 is going to start off as 0 minus 1, which is negative 1, which is a valid number. And it's a valid index. It's just that num represents the first number, and list sub negative 1 represents the last number, and however long your list is the last number. And we don't want to compare those. So yeah, we're just going to skip the 0th index, right? So if num equals so if the current number, which is num, equals list sub negative 1, which is the prior number. So the current number equals the prior number plus 1. Then that's valid. In this case, it's more interesting to me to check if it's not equal to that. If it's not equal to that, then I know it's not a continuous set and I can return false. If it is equal, or if I make it through without returning false, then I can just return true. So if I make it all the way through, checking every number against the previous number, in this way. Let me see if I can make this a little clearer. I feel like I could make this clearer. Oh. So let's call this current num. And then let's just do this. Previous num equals list sub idx minus 1. That's the previous number. So if the current number is not equal to 1 more than the previous number, then it's not a continuous set. We don't need to do anything else. We'll just return stop executing code, and that should do fine. Well, let me run it against my tests here. We should get false and then true. False and true. Okay. Let's see what learn has to say about it. Correct. Oh, this is an interesting way of doing it. I didn't think about that. This is cool. I think I like this better. So here we take the min and the max. So it's going to set the upper and lower bound of the set. And I wonder if you just subtracted, like got the difference of them, and if the length was not equal to the difference. Ooh, I got to try that. I have to try that, but let's go through this. We've got this test set if or for val in, so this we use the min and the max to create a range, inclusive of the upper bound from the min to the max. And we add it to the test set, and then we see if the union of set 1 and test set equals set 1. So if the union is the elements that's in both of them, yeah. So it's sort of leveraging the behavior of range to do this. But I think I just have to try this solution because I think it'd be cool if this works. I'm not sure it will, but we'll see. Okay, so we'll just say return max set. I'm going to call it set underscore max minus min I'm wondering now, is that going to work? Yeah, because I want the space between them. So, you know, like if I've got elements in my set, like let's say the elements are 1, or let's say they're 20, 21, 22, and 100. The min and the max are going to be 20 and 100. 100 minus 20 is 80. The length of the set is 3, though. So if the numbers are continuous, or I would have used the word contiguous, but if they're continuous, probably makes more sense to say continuous. Yeah. If they're continuous, that difference of max minus min is going to be equal to the number of elements in the set. And if they're not, then it won't be. Okay, so max minus min equal to, can I do len for set? I think I can. I don't recall if len works on sets. I believe it does, but we'll see. Ah, now that is totally fascinating. We got exactly the wrong results there. True, false? Huh. Wow. Now I wonder if I wonder if like len has some unexpected behavior. Four, that's 1, 2, 3, 4, and 6. 1, 2, 3, 4, 5, 6. Okay. Okay. So, oh yeah. Well, that's not gonna work at all. That is not gonna work at all. Wow, I was so stoked about that, but now it's very clear to me that won't work. I feel like I'm onto something with this. I feel like it could be done. It's probably painfully obvious, but alas, I'll move on. Cool. I can't stop thinking about it. I have to try. One more thing. Okay. If this doesn't actually work, then I promise I'll move on. Range. So we'll do range from min to max. +1. No, what am I doing? Len of the range equals len of the set. False and false. That doesn't work either. Okay. I promised I'd move on. Whew. I have to play with that on my own. Cool. Yeah, I'll give another minute for folks to get things in, and we can go from there. Okay, I'm not seeing anything else. I can't let it go, though. I do have to try with this one. Okay, so that does work. I inverted this range by accident. I was starting at max and going to min, which means I was starting at a higher number and ending at a lower number. Range is not smart enough to like count from high to low. It just doesn't give me any range. It's just an inverted or a negative range. And I just didn't see that it was min to max there. So, yep, that's an alternative. So we're just creating a set out of range from min to max plus 1 and seeing if it's equal to the original set. Okay. So since I'm not seeing any other questions, that's fine. I will go through the material. So last few study halls we've been going over while loops. We talked about like open-ended problems and checking conditions in various ways to control and break while loops. This is a really common use case for while loops is in a menu, like having a main loop in your program, or you take in input from the user and then you wait for that user input, and then based on that input, once the user puts in input, based on that input, you process it and do whatever you need to do with it. You set the next program state, changing whatever variables and whatever you wanted to do with that input, and then you ask the user again, like, do they want to do another input or whatever. So while loops are often good for menus. So keep in mind that a menu can be a list of selections. Blah, blah, blah. Okay, I'm not going to read through that. So this is a little like restaurant ordering thing, an actual restaurant menu. So while another order equals true, that's really funny code that's in there. This is just going to be true or false anyway, so we don't need to check if it's equal to true. So we do need to initialize it though with a value of true. And this will say we have our menu string here, select from this list, and we give the user the opportunity to select several menu items, and then we just print the menu list. We ask for user input, we cast it as an int, it says please make a selection 1 through 4, turns that into an integer and selects the appropriate item, right? So this says if the input, which is an integer, is in a list of 1, 2, 3, 4, if it's in a list of 1, 2, 3, and 4, then selections.append input. We're going to append that input. Else print your selection was not understood. This continue is going to send us back to the top of the loop. It's just like continue means skip the rest of the code in there. So prints that you made a bad selection and then gives you the opportunity to select again. Then we ask for input again, imp2, and says, would you like to place another order, yes or no? And if it equals yes, then we continue, we don't do anything. Else another order equals false. Since another order is equal to false here, this is going to propagate up to here. We're going to end the loop, and this will break the loop. I'm tempted to just do this, and then just say break right here. We'll check this negative condition and get rid of the superfluous code. So if the input is not equal to y, then just break. And you know what? I'd actually probably put this up here. Would you like to place an order? Yes or no? Something cool that you can do here, you can just take your input right in your if. It'll ask for input right here, and then it'll evaluate that accordingly. So if the input is not equal to a y, then we break. Yeah, okay, cool. So let's run this. Would you like to place an order? Yes. Select from this list: bread, butter, potatoes, and broccoli. I want broccoli. Name is not defined. Okay. Do I have some other name is not defined? Oh, name selections is not defined? Right. I have to have a list of selections. There we go. Yes. Broccoli. Place an order. Yes. More broccoli. Yes. Bread. Yes. And then let's do an invalid input. Let's say like 6. It says your selection is not understood. Do you want to place an order? Yes. Okay, so we fed it some numbers there, or some letters, and we tried to cast that as an int, and it didn't know how to do that, so it threw us an error. Run this again. Place an order, yes. Broccoli, yes. Broccoli, yes. Bread, 5 is not going to be understood. Oops, well, that was asking me yes or no, but I entered something that wasn't yes, so it exited. So this is my list. All right, cool. So this is a nice thing. The scariness of while loops kind of goes away a lot when you're using input inside of them, because I mean this is technically potentially an infinite loop, but it'll just exit when I ask it to. So this is still fits under the heading of a problem that you don't know how many iterations it will take to complete, right? Well, it takes as many iterations as the user wants. You know, that's a subject of what the user wants. So it's funny because I tend to like discourage people from using input and while loops, but using them together kind of makes them both make sense. So they go together really well. And if you put them together, you're probably kind of building some kind of menu. Okay. So let's go through these. So which of the below loops would run infinitely? I think it's going to be this one. So x equals 0 while x is less than or equal to 144. We're going to decrement x. So this condition starts off true, and it'll never, since it loops while x is less than 144, and we're decrementing x is just going to get further and further away from 144. So it's going to be option A. We've got some multiple options here. So I got to check B, D, and C as well. A definitely will. I wonder if I check C and D. I need to just check C and D. No, I need to check them all. Okay. X equals 144 while x is greater than 169. So this won't run at all because its initial state is that x is less than 169. So this is a while false. We're not going to do any iterations at all. 169 while x is less than or equal to 196, x plus equals 1. So we start with x lower than our target, and we increment in the direction of the target. We're checking if it's less than or equal, so this will stop eventually. X equals 169, while x is less than or equal to 225, that's true. This initial state is true. And then this is going to decrement again, so that'll get further away from 225. So it's exactly the same as the first one. So that's going to be A and D, or D and A. Cool. And again, I mean, just feel free to put in a question. We usually wrap up around 5:30, so, or 5:30 for me. I'm in Mountain Time. Apologies if you're somewhere else, you know, if that's not your time or whatever. But yeah, we'll usually wrap up pretty close to this time. So I'll just go through these last two. But if somebody gets a question in the next few minutes, I'll be happy to take it. So last call for questions. So what code needs to be added and the two blanks for the following function to make the loop terminate? So we have this. Let's see what options. So keep going starts off as true. So let's see. I think 1 is a contender. Or this first one here, this is a contender. And keep going equals false. Okay. Yeah, so this is saying this go on variable is equal to, would you like to keep playing? Enter y for yes, or n for no. Go on equals, if go on is not equal to y, then we want to change keep going to false. So it's definitely this first one. Cool. All right. We're getting into a new section. I'm not seeing any new questions, so rather than kind of starting and not being able to really meaningfully get into this new section, I think I'll just wrap up here for today. Thanks for everybody who participated. Thank you to you all. I do appreciate the questions. Everybody's welcome. Just go ahead and pop in your questions in the Slack thread, and I'll be happy to get to them. Feel free to hit me up on Slack if you have any questions, and I'll get back to you as soon as I can. If you're in Premium Prep, then I'll be teaching tonight, and I'll see you there. If not, I'll see you this Wednesday, which will be the next study hall stream. So yeah, have a good rest of your day, and yeah, I'll see you later.